At number 5, which says blah blah blah, the square roots can be expressed in the Cartesian form x plus y or I, where x and y are real and exact. I'm just reading, but this is nonsense. Basically, this is nonsense. Look at this. By first forming a quadratic equation, find the square roots of this. Good. So even if they did not say find the square roots, you are still going to have an equation which would be quadratic. Let's talk about this. Now, here's what I want you to know. And you're going to see how the equation is going to be quadratic. I said that. I clearly told you that in complex numbers, please expect a question that asks you to solve an equation. Now, there are 4 different ways that you may be asked to solve. A question could, you see, this is a long thing, and I want you to go check the video, which I'm going to put in the description. And this video is going to be explaining to you how or the types of questions that you get in this section of solving equations. Now, here I'm just going to summarize it by saying, everyone knows that when we did quadratic equations, we could find a situation that had no real solutions. So if you have no real solutions, then what type of solutions did you have? We say you have imaginary solutions. When you get to a situation where you have a square root of a negative number as your solution, x or whatever equal to this, you understand? We'd say this x has no real solutions because this thing inside was the discriminant, which is b squared minus 4ac if we use the quadratic formula. And when we get it as negative, we'd say, oh, there are no real solutions. But now we are saying the solution is there, but it's imaginary, it's complex. So now we are going to be solving. Now what I want you to know is you are going to be given equations to solve. And it's really hard for me to tell you everything that I want to say because there are things that I just want you to see and picture, because I know you do have a lot of questions like what would be the equation looking like? How do we solve it? It will be looking exactly like the equations that we do in algebra, but only that usually instead of x it will be having a z. We'll be using the same things we used, the factor theorem, remainder theorem type stuff. We're going to be using it here. Polynomial division, we're going to be using it here. But the only difference is when you get to the final solution, when you are solving the equation, in terms of solving, you solve it the same way you solve the other types of equations. But when you get to the final solution, you are going to have a complex solution, which will have a real part and an imaginary part. We know that a complex number will be in the form, say z is equal to x plus iy. Okay, you put I before the number, right? Then this is going to be what your solution is going to be like. We'll get to that example, but that is what you would get the final solution as having. But the whole time you'll be working with your z's. They would just be like a quadratic thing or a quadratic thing. And actually the types of equations you're going to get are going to be quadratic and cubic. Okay, quadratic equations and cubic equations. We're going to have quadratic equations to solve, and we're going to have cubic equations to solve. Are we together? And you can also get quadratic. Now, here's the thing I want you to know. Just one more thing. Okay, I'm going to get a cubic equation. How do you solve a cubic equation? Remember, you are going to do some polynomial division type of thing, okay? How do you solve a quadratic equation? You're going to do some polynomial division type of thing. But here's what they'll do. They'll always give you one factor. And if they say, for example, they give you a root to say, z is equal to 4 is a root. That means you are going to have a factor z minus 4, and then you do long division to find the other things. Then for quadratic, let's say they say to you, for example, they say to you, let's say z minus 2i is a factor. Then that means you are going to have another factor, which is going to be z plus 2i. Okay, because when you get a factor that is a complex, just know that its conjugate is also a factor. If you ever get a factor, just know that its conjugate is also a factor. Then you're going to multiply them together. You're going to get some x squared. When you get something, you now do long division, and you would find another quadratic, which you then solve. So what am I going to do? If I have a cubic, I'll be given one root, which I change to a factor, then I do long division. If I get a quadratic, I'll be given a complex one, which I'll get the conjugate, then I'll expand them. The two conjugates multiply together, right? the two conjugate multiply together and they give me something, and then I'll do long division with that answer. Fine. That's what you're going to do, right? Always remember that that's what you're going to do. Now, the thing is, I want you to also know that when you're getting solutions, I want to give you the numbers. You say to me, how many complex solutions do I get when something is cubic? When something is cubic, it means there's an x cubed. It means it has 3 answers. And for 3 answers, you get 2 complex, okay? And 1 real, okay? 2 complex and 1 real. Or you are going to get 3 real. You can never have complex solutions, can only be 2 or 4. 2 or 4. 2 or 4. So when I have cubic, they can only be 2. They can't be 4, right? Because cubic has a total of 3 answers, so obviously 2 will be complex. For quartic, how many are complex? Complex can only be 2 or 4. Come on. So for quartic, I can have, remember quartic will have 4 solutions. You have an x to the 4. So you have 2 complex and 2 real. Okay? Or you are going to have 4 complex, or you are going to have 4 real. This is what you have. You understand? This is what you're going to have. So complex can only be 2 or 4. Okay? And for 4 real, that means there would be 0 complex. Now, either way, these are just the numbers of things, but we don't need to know. Now, let's see here what we have. Now, there's another question. There are 2 more questions. Remember, I said first, the 2 questions will be saying either solve the equation, or they'll be saying either it will say solve the equation, or it will say to you, find all the solutions, find all the complex solutions, right? Which is still solving the equation. Now, we said when you get a factor that is complex, you put the conjugate, you expand, you're going to get something, and that's something you do long division with it. Okay, and then when you get one solution, you just do long division with it, and then you're going to get something which is quadratic, and then you solve the quadratic one using the quadratic formula. Here you are going to expand, get something quadratic, divide into the power of 4 thing, you get another quadratic, you now solve it by using the quadratic formula. When you use the quadratic formula, you get your solutions, and we'll be moving on like that. Now, there are 2 other types of solutions, and one is here. Find the square roots. There are 2 other types of questions. You are asked 4 types of questions. One is find the square roots, and then the other one will be saying solve, and you'll be having a cube root, but that cube root will be like, let's say they say to you, solve z cubed is equal to 8. Okay? Right. This one, or z cubed is equal to 27. You'd need to solve this and find all solutions, and I'll show you how you're going to do it. This is called the cube roots of 1. Okay, the cube roots of unity, or the cube roots of 1. Now, we're going to see how to do this one, and the other one is by finding square roots. So what did we have? We had where we are finding the solutions, or we said you are either told to solve the equation, or you're told to find the complex solutions, and you are given a factor for a cubic, or you are given one factor which is complex for a quartic, and you can solve the equation or find the complex solutions. And then we say the other question will be saying find the square roots, and this is the one we are doing here. You need to know that's the 3rd type of question you can get. The first one is to solve an equation and it is cubic. The second one is to solve an equation and it is quartic. You always be given the first factor on these ones, okay? Then the other one is now to find the square roots. Then the last one is to solve, and that equation will be a cubic equation, like to say z cubed is equal to 27. And then you have to find 3 solutions from here. Wow, really? Yes. We'll see how to do it. Now let's start by doing this one, which is the 3rd type of question. Let's solve it now. Okay, let's do this type of question. Find the cube roots. This is actually solving an equation, finding the square roots of a complex number. That's what we say. So this is not a new statement. This one you would have learned it, to how you find square roots of a complex number. Let's now do it, and let's see how we find square root of a complex number. So what you're going to do is you are just going to say, since they want the square root, you are going to create a complex number which is equal to the thing you want to find square root of. So we want to find square root of this. So we are going to say the square root of this will be equal to some other complex number. So you're going to say let x plus iy be equal to the square root which you want. You want the square root of this thing here. So it's the square root of minus 4 plus 6 root 5i. Now we are going to start. This is how you start. You create a complex thing and you make it be equal to the thing you want to get square root of. You make it be equal to the square root thing. And remember, square root has plus or minus. You make it be equal to the square root because you want to find the square root. So the complex solution is going to be equal to the square root. Now what do? We always then take the square root to the other side. It becomes squared. So now what are we going to write? We're going to write to say x plus iy, all squared will be equal to now minus 4 plus 6 root 5I. Then now let's expand. X plus iy all squared. How do we expand it? You square the first, you get x squared plus. You multiply this together, then you double it. X times iy is xyi. But then you double that. So you say this times this, you get an answer. Then you say times 2 because it's going to happen 2. So it'll be 2xy of I. Then what is the last one? You square the last one. This is plus I squared y squared. And this will be equal to minus 4 plus 6 root 5I. Now, there is nothing called I squared. We should know that I squared is equal to a negative 1. So whenever we get I squared, we change it to what it means. So here we are going to have x squared plus 2xyi minus 1 of y squared. So we just change the sign. So plus 2xyi minus y squared. This is equal to minus 4 plus 6 root 5I, because there's nothing called I squared. Don't ever forget. Now we're going to say x squared minus y squared plus 2xyi is equal to minus 4 plus 6 root 5I. So we will now equate the real part and we're going to equate the imaginary part because these two equations are equal. So we're going to say x squared minus y squared should be equal to 4 because that's the real part. Is it equal to 4? Can I negative 4? It is equal to negative 4. X squared minus y squared is equal to negative 4. Are you seeing this? Then what are we going to have? This is going to be equation number 1, which we can make x squared the subject to say x squared is equal to negative 4 plus y squared. Or we can say x squared is equal to y squared minus 4. Then here, this is going to be our equation number 1.